Hello, so today I'm going to present my poster in front of you. So the title of my poster is the Bimodal Data Analysis for the Early Detection of Lameness in Dairy Cattle using the Artificial Intelligence. So now moving on to the introduction. So what is lameness? So lameness is a condition in dairy cows that affects the locomotion system of the cows, particularly the limbs. So the main reasons for the causation of the lameness in dairy cows, the hoof lesions or the injuries of the limbs in the dairy cows. So why the research regarding the lameness was important? Because lameness is the third most significant health issue in dairy cattle herds after the fertility and mastitis. And moreover, it affects the 35% of the dairy cattle in Canada, highlighting a major concern in dairy farming. So our current detection challenges was that like the current detection techniques like the body condition scoring and the five-point scoring system often detect the lameness after the significant symptoms appear, so leading to a delayed treatment and a prolonged animal suffering. So now moving on to the objective of a study. So the first objective is to utilize a DenseNet AI model to analyze the biometric facial data, identifying stress indicators from the images and videos. So second objective is examining accelerometer data to detect the digital markers that signal lameness in the dairy cows, and in the end we will integrate these insights to accurately predict the early signs of lameness, facilitating the prompt veterinary intervention and the adjustment in the managements. So now moving on to the methodology of our project. So basically we divided the methodology in the two phases. On the first phase, I collected the facial biometric data from the 6 Holstein cows over the 21 days at Ruminant Animal Centre at the Dalhousie Agricultural Campus. So I collected 7,000 images and 1,000 videos from the RAG center here, and concurrently we also collected the accelerometer data from the 4 cows using the Fibion Sens motion sensor. So our plan for the phase 2 is to collect the facial biometric data from an expanded group of 500 cows to further validate the model. So here you can see the pictures of our Ruminant Animal Care Center, the picture of a sense motion sensor, and the staff installing the sense motion sensor on the hind leg of the cow using a Velcro strap. And here I am taking the collecting the facial biometric data of the cows using a smartphone. So now moving on to the results. So the first graph is the comparison of the activity matrix for healthy and lame cows within the each cluster. So from the graph, the graph illustrates that the healthy cows typically display higher activity across various metrics compared to the lame cows, but in some of the metrics you will see the lame cows depict more activity levels, because the reason for this is that due to the discomfort faced by the lameness issues, say they like a kind of sit down more or stand more frequently than the healthy cows. That's why in the some of the metrics like sporadic walking, they show more activities. The same is with the second graph. Overall, it's a time series analysis of the activity levels of the cows. So overall, the healthy cows are more active than the lame cows, as we can see from the accelerometer data after analysis of the accelerometer data. Moving on to the confusion matrix. So it depicts that our model is 93% precise. So the precision is literally good for our DenseNet AI model. And here also the DenseNet AI model classification report depicts that the precision levels are 93%. And the F1 score is also 93%. That's really good for an AI model. So now moving on to the conclusions of our study. So basically, integrating the visual and accelerometer data significantly improves the early detection of lameness by uncovering the new indicators. And the new indicators are crucial features like facial tension indicators, gait abnormalities, and activity variations and behavioral changes that are not detectable with a single data type. So our AI model ability to detect these nuanced feature enables early and more accurate identification of lameness, facilitating prompt veterinary care and management adjustments. So our proactive approach enhances cow welfare and minimizes economic losses in dairy farming by addressing health issues before they escalate. And in the end, I would like to thank you. I would like to acknowledge all the contributors of our project and all the RAG staff that help us in the planning of our project at the Dalhousie Agriculture Campus. Thank you.